Okay, so in number 2,
He's recording! Oh my god,
in number 2, look at your paper. Look at your paper. So the question is, or the problem is, we need to find the prime factorization of each of the following numbers, leaving your answer or answers in index notation. So there's a condition that when you have found the answer, you have to write it in the index notation. The first number that I gave you is 324. So how do we write this number using or the prime factorization? Any technique that you use? Like how do we break this down?
You do like, you divide it by 2, and then you get the answer, and then you do like arrows.
Okay, like a tree diagram. Okay, but you said we could divide the number by 2. So you are suggesting that we use a small number, right? So if we divide 324 by 2, what will be the result? 162. Okay, and then what should we do with 2 and 162?
You can divide it by 2 again.
By 2 again. Okay, so for your tree diagram, this is how you should do it. So bring down the number 2 because we can't do factoring for 2 anymore aside from 1 and 2. So we break down 162 into 2 numbers. So any suggestion?
The divided by 2 is 81.
Okay, we divide by 2 again. So if you notice, there is a certain pattern in our procedure. So we keep on dividing by 2. So 162 divided by 2 is 81. And then we break down the number again. So we keep on copying these numbers, 2 and 2. Because you can't do anything on the 2 and 2. Yeah, always bring down the 2's. Okay, 81. So can we divide 81 by 2? Can we divide 81 by 2?
Yes, no, you can divide it by 9.
You can divide it by 9. Okay, so if you think that 81 is divisible by 9, you could do that as well. But my question was, why can't you divide it by 2?
Because the last number is 1.
The last number is 1, so 81 is what kind of number? Odd number, right? Okay, so you cannot divide an odd number by an even number. If you divide, then you will have a remainder. So you could break 81 into 9 and 9. But we could still break down 9. So 3 and 3. So we keep on copying 2 and 2. 9 will become 3 and 3. So is the other 9, so it becomes 3 and 3. Okay, the prime factorization of 324 is 2 times 2 times 3 times 3 times 3 times 3. Right? We count 1, 2, there are 2 2's and we have 4 3's. Okay? So that's the prime factorization. And if you notice, we arrange the numbers like the smaller number first before the higher number. So 2 is smaller than 3. So we wrote 2 first before the 3. But remember, there is a condition that you have to write your final answer in index notation. How do we write 2 times 2 times 3 times 3 times 3 times 3 into index notation? Yes?
2, and then a small 2 at the top.
Okay, so small 2 means, what's the name of, how do we call these small numbers on top of, how do you call this number? In math, we call this number as exponent or the index. That is why it is said you have to convert it into index notation. So exponent notation. So 2 squared, so we say 2 squared, but what about the 3?
Then you have to count how many 3's there are.
Okay, so we have to count. So how many 3's do we have? There are 4. So that means you have 3 to the 4th. Okay? So 2 squared times...
You only have to list down the recent 2's. You don't put the 2's before that. Just the 2's that are already there.
Yeah, you only collect what's in the final line. Okay, if you look at our tree diagram,
You didn't put the other video in the Google Classroom. So
not yet.
You're gonna put it in.
Not yet.
What do you mean not yet?
I'll upload that later on.
Are you gonna post this video?
Yeah, for your review.
Okay.
So you'd go back to your, paper, review it again. So if you forgot something, then you could always refer to the video. Okay? But did you get the main idea? Because the numbers will change, but how to get the prime factors will be the same. Okay. Let's get the other number. So this time it's for practice. So let's have B is 600. So let's do this with the same technique. Any suggestion how to break down 600? By 2 again. I want it to be 10. Okay, 10 and 60. Okay. Now, don't think that it's always 10 and 60. You could always pick any combination. Okay? Yes. Okay, you can start with 2 again. You can have 3, but if you want 10 and 60, that's fine. Okay? In doing so, 10 will become what? 5 and 2. 60 is 10 and 6. Okay. So that's a new line. And then can we do anything with 2? No, so we just copy. 5 is already a prime number, right? 5 is a prime number. Okay, 6. Break down 6. 3 and 2. 5 and 2. Or 2 and 5. Okay? So once all the numbers are prime numbers in your line, this is the latest line that we have, then that means we have already performed the whole process of prime factorization. Okay, so let's write this again in order. So 2 times, how many 2's do we have? 2 times 2 times 3 times 5 times 5. If I didn't ask you to write it in index notation, then this is already finished, right? Okay. But we need to write this in index notation. So we count. So 2, how many? 3, and then times 3 times 5 to the 2. And that's a prime factorization in index notation. Okay, so are there any questions? Okay, so that's how you do the prime factorization. Let's just put a title for this. So prime factorization. Okay, so that's it for this one. Okay.